Hello, welcome to Pragim Technologies. I am Venkat. This is part 48 of SQL Server. In this session, we'll learn about derived tables and common table expressions. We'll compare these with other constructs that are available in SQL Server like views, table variables, local and global temporary tables. Let's start with an example. I have TBL department table here which has got department ID and department name columns, TBL employee table here which has got ID, name, gender and department ID columns. Now let's say I want you to join these two tables and produce the output that you can see on the right hand side here. I want the department name and the total number of employees within that department. But then your list should only include those departments which has got 2 or more employees. And obviously to achieve this output we have several ways. But then we will see how to do that using views. Okay, so we are creating a view here, create view name, as we are selecting the department name, department ID and count of star, which would count the number of employees within that department, and we are giving it an alias called total employees. From TBL employee join with TBL department, and obviously between these two tables department ID is the column that's common, so we are joining those two tables on that column, and you will have to group by department name, department ID because we want the count. And we have spoken about joins and group by in a very great detail in the previous sessions of this video series, so please check that part. And we have spoken about views as well. Okay, so we are creating this view. So once we have this view, it's very easy to compute this result that you want. So the columns that you want are the department name and total employees. So obviously we have those columns in the view, department name and total employees. All you have to do is select those columns from that view and then select only those departments which has got total employees count greater than or equal to 2, which will give us this output. Okay, but then let's say if we are using this view only within this query, then it doesn't really make sense to create a view for that purpose. That's why we have other constructs in SQL Server which we'll be exploring next. So views get saved in the database and can be available to other queries and stored procedures as well. So if you are using this view in other stored procedures and in other queries, then that's fine. But then if you're using this as a one-time just this one time in this query, then it doesn't really make sense to have this view created. We can make use of other constructs that are available in SQL Server like CTE, derived tables, temp tables, table variables, etc., which we'll be talking now. Alright, let's look at this in action. So we have these two tables, TBL employee, TBL department, the data. Okay, so let's create this view, execute, command completed successfully. So when we refresh this folder, we should see the view there. So views get physically stored in the database. Now if you want the columns from that view, look at this, we have all the columns from the view. Select star from, if you say view, it would return all the columns. Within the view we have got 3 columns, department name, department ID and total employees. But then in our output we are only expecting department name and total employees, so we are only selecting the required columns, department name, total employees from that view where total employees is greater than or equal to 2, which would return IT and HR departments. So let's execute that query and we only get that. Alright, but then if you're using this view just in this query, then it doesn't really make sense to create a view. Alright, let's see how to achieve the same thing using temporary tables. So obviously the logic to calculate the department name and total employees, it's exactly the same. We have this query will not change. It's just that we are going to use that with other constructs that are available in SQL Server. So here we are using temporary tables. Okay, so the query is the same. Select department name, department ID, count of star as total employees. We are giving it an alias and we are selecting these columns into hash temp employee count. This is the temporary table. So you might be wondering, where did you define the columns that this temporary table has? When you use select into syntax, what's going to happen behind the scenes, SQL Server will create those columns for us automatically. You don't have to define the structure of the temporary table. So we are selecting these columns into this temporary table. The rest of the logic is the same. We are joining TBL employee with TBL department on department ID column and grouping them by department name and department ID columns. Okay, so this logic remains same. It's just that you're selecting that data into this temporary table. And then what you're doing, it's pretty much same after that. You want the department name, TBL total employees. Instead of the view, you're saying from the temporary table where total employees count is greater than or equal to 2. Okay, let's look at this in action. And remember, since this is a temporary table, it's a good practice to actually drop the table after you have finished using it. And remember, there are two types of temporary tables: local temporary tables and global temporary tables. Depending on the type of temporary table you are creating, the scope differs. Okay, and temporary tables are stored in tempdb. Local temporary tables are visible only in the current session and can be shared between nested stored procedures. Meaning, if you have created a stored procedure, a temporary table in stored procedure A, and if stored procedure A calls stored procedure B, then the temporary table that you have created in stored procedure A will be available in stored procedure B. So local temporary tables are visible in the current session, only in the current session, and can be shared between nested stored procedure calls. Whereas global temporary tables are visible to all the sessions and are destroyed when the last connection referencing that table is closed. That global temporary table is basically closed. Let's look at this in action. So we are selecting these columns, department name, department ID, count of star, into this temporary table. So let's execute that. So we should have the temporary table created now. So obviously, when we say select star from that temporary table, you should see all the rows and columns. So select star from the temporary table, which here is temp employee count. Since we have a single pound sign, it's a local temporary tables. We have spoken about temporary tables in a great detail in the previous sessions of this video series. So if you're new, check those parts first. So we have these columns. So obviously, if you want only those department name and total employees columns, you select those two columns from that temporary table where total employees is greater than or equal to 2. So when we execute this query, we get the expected output. So the output is exactly similar, except that here we are making use of temporary tables instead of a view. Alright, now let's look at how to do exactly the same thing using a table variable. Now, when we created the temporary table, we didn't define the structure. The structure is automatically inferred based on the select statement that you're using here, because you're using select into. But then when you're using table variable, here we are defining the structure explicitly. So declare a table variable, a variable, and this variable is of type table. Obviously, if it's a table will have columns and data types, so you'll have to define them as well. So this table is going to have department name, department ID, and total employees, just like how we have this view: department name, department ID, and total employees columns. Okay, so next what we are doing, we are inserting into that table variable department name. This logic remains the same. The query is exactly the same. We are selecting department name, department ID, count of star from TBL employee, joining that with TBL department on department ID columns, and then finally grouping it by department name and department ID. So now we have this table variable. From the table variable, you can select the required columns, department name and total employees, where total employees is greater than or equal to 2. So it's exactly similar. In the previous example, we were using temporary table. In this example, we are using a table variable. Okay, just like temporary tables, a table variable is also created in the tempdb. Most of the people think table variable is actually created in memory, which is not true. Both temporary tables and table variables are created in the tempdb. The scope of a table variable is the batch or the stored procedure or a statement block in which it is declared. But the advantage of using table variables is that you can pass them as parameters between procedure calls, between one procedure to another procedure. Okay, so let's look at this in action. Obviously, it's a very good practice to drop temporary tables, so let's drop that table. Even if we don't drop a local temporary table, it gets automatically dropped when the session that has created it is closed. So using table variable, we are creating the table structure here. Declare the table variable, specify the column names and the data types, and then insert into that table variable, and then select whatever columns you want from that table variable. So let's execute this. We should see the same output, except that we are using the table variable. And the advantage of using table variable is that you don't have to drop it like temporary tables. But there are several other differences as well between table variables and temporary tables. Alright, so we can also achieve the same thing using derived tables. Now look at this. When we created a table variable, we will have to define the columns and the data types for a table variable. But whereas if you are using a derived table, this table is derived, so you don't really define a table as such, you just give it an alias. So if you look at this, this is the query that we have been looking at all this while. Select department name, department ID, count of star as total employees from TBL employee, joining that with TBL department, the same query here. Now if you look at this, this query is wrapped between these brackets, and then you're saying as employee count. So this entire thing from this bracket to this bracket, is considered as a table, okay, a derived table, and you are giving that table a name, employee count. And then if you look at this, the columns that are present in this table are nothing but the columns in the select list here. So you have department name, department ID, and total employees columns. Okay, so now you treat this from here till here as a table. So you treat this as a table, employee count. So select department name, total employees from this employee count, where total employees is greater than or equal to 2. So here, this is a derived table. This employee count is a derived table. And derived tables are available only in the context of the current query. Here, this select statement. If you have another select statement, beneath that, this derived table is not available for that select statement. It's only available here within this context. So let's look at this in action. So if you look at this one, if I execute this, it gives us those columns, department name, department ID, and total employees, all those columns. But then what we are essentially doing here is wrapping that inside these brackets and then giving it a name. And this name can be treated as a table by itself, which has got these 3 columns. And what you're doing from these 3 columns, you're selecting just department name and total employees columns. And then you're filtering on that column, so where total employees is greater than or equal to 2. So obviously we only get those 2 rows where the employees count is greater than or equal to 2, which in this case is IT and HR, just like other examples that we have seen. And finally, we will see how to achieve the same thing using something called CTE, Common Table Expression. We will be talking about CTEs in a great detail in the next session. This is just an introduction to CTE. So achieving the same output with using a CTE, Common Table Expression. And CTEs are introduced in SQL Server 2005. So if you look at this one, this is again very simple. Okay, so the exact same query that we have been working with, this query that you can see here. Now what we have done is we use this keyword with and then you have given a name. This is nothing but the common table expression name, CTE name. So with employee count is the name of your CTE. And then you can specify the columns that your CTE returns. Okay, this part is optional. If this query is returning a unique column names, then you don't have to define this column list. Okay, but I have defined it here just to be clear. So this common table expression, employee count, is having 3 columns: department name, department ID, total employees. Okay, where are these columns coming from? These columns are coming from the select query. So this select query, look at this, we have the brackets here. So this is like a table. What is the name of this table? Employee count. And this is a CTE, so we use the with keyword. So usually the syntax for CTE is in such a way that you use the with keyword with CTE name, the columns that your CTE returns as, and your select query. Your select query actually determines what columns are being returned by the CTE. Alright, so we are done. This is pretty much similar to derived table. And if you look at this derived table, this query returns, it's like a table. You're just naming it as employee count. Along the same lines, for a CTE, this query, and you're saying with CTE name and the columns as, and then your query obviously. And then what you can do is, since this is treated as a table now, a common table expression, and this common table expression has got 3 columns, just like derived table. And out of those 3 columns, we just want the department name and total employees columns from that CTE, which is employee count here, where total employees greater than or equal to 2. So we get the same output. Let's look that in action. So that's the CTE. So let's execute this, and we should get the same output. Alright, a CTE can be thought of as a temporary result set. It's a temporary table, or you can also think of as a derived table that is defined within the execution scope of a single select, insert, update, delete, or create view statement. You can use this CTE even within a view. Okay, but this is defined only within the execution scope of a single select, insert, update, delete, or create view statement. Now if this is a little confusing what we mean by this, we're going to talk about common table expressions in a great detail in the next session. I will explain this definition clearly in the next video session. And a CTE is similar to a derived table in that it is not stored as an object and lasts only for the duration of the query. So this is not being stored as a temporary table or a view. Okay, it only lasts for the duration of this query. Outside the context of this query, the CTE doesn't really have any meaning. We'll talk about CTEs in a great detail in the next session of this video series. On this slide, you can find resources for ASP.NET C# and SQL Server interview questions. That's it for today. Thank you for listening. Have a great day.